Hello and welcome to another video of Cornerstones of Math. Today we are going to calculate this limit. Limit as n approaches infinity, 2n factorial divided by n factorial times n to the power of n, and this entire thing raised to the power of 1 over n. So the basic method is like this. The expression involves factorials and power of n, which roughly means a product of many stuffs. And the thing is, the product of many stuffs are quite difficult to handle. So we are going to change this product into sum, which can be done by logarithm. So let an be this entire thing. And let us take a natural logarithm of an and denote it as bn. Then we calculate the limit of bn, which would be some number beta if it converges. Then from here, an equals e to the bn, so the limit of an is simply the limit of e to the bn, so e to the limit of bn, which is e to the beta. And this is our problem solving step. Quite simple, right? Now some of you might want to ask, how can you guarantee that this works? Well, this is where some fancy analysis stuff comes in, which I think is a bit too advanced for this video. So here, let's just accept without a strict proof that this indeed works when the function is, say, nice and continuous, such as this simple exponential function. Alright, now let's simplify this bn. So bn, which is ln an, is ln of 2n factorial over n factorial times n to the power of n, raised to the power of 1 over n. So this 1 over n can come to the front. And then, if you divide the 2n factorial with n factorial, what's left in the numerator is n plus 1 times n plus 2 times so on, all the way up to 2n. And then we have this n to the power of n term. So we have this. Now here, this n to the n simply means that n is multiplied n times, and if we take a look at the numerator, you can see that it is also a product of n terms. Therefore, we can write n plus 1 over n times n plus 2 over n times so on, and 2n is basically n plus n, so we have n plus n over n. Now, the first term can be written as 1 plus 1 over n, and the second term can be written as 1 plus 2 over n, and the last term can be written as 1 plus n over n. And we can split this into sum of logarithms, which is 1 over n times ln 1 plus 1 over n plus ln 1 plus 2 over n plus ln 1 plus n over n. In sigma notation, we have sigma ln 1 plus k over n, where k is from 1 to n. So this is bn. Therefore, the limit of bn, which is the limit of ln an, is the limit of this. And as you see, this series can be easily converted into integral. So we replace k over n to x and 1 over n to dx. And the interval is from 0 to 1, so we have this integral. And this integral can be calculated using integration by parts. But here, we don't have two functions. So what we do is consider this integrand as 1 times ln 1 over x, and let v prime as 1 and u as ln 1 plus x. Then we have v equals x and u prime equals 1 over 1 plus x. Therefore, we have uv, so x ln 1 plus x with 0 and 1, minus integral u prime v, so x over 1 plus x. So the first term gives ln 2, and for the second term, we make the numerator 1 plus x minus 1. So it gives 1 minus 1 over 1 plus x, which gives ln 2 minus x minus ln 1 plus x. Now this entire term becomes 0 when x equals 0, so we only have to subtract the number obtained by letting x equals 1. And that number is 1 minus ln 2. So we have 2 ln 2 minus 1, which is ln 4 over e. And this is the limit of ln an. So the limit of an, which is limit of this, is simply 4 over e. And there we have our answer. Thank you for watching, and I will see you in another video.